Alright, adding vectors with components. Hopefully you looked at the first video, adding vectors and subtracting vectors. Now what happens is a lot of your examples are nice little right-angled triangle examples where you end up with maybe that one, that one. You go, okay, what's the resultant vector? Vi plus V2 equals V3. And it becomes quite easy. But what if you have a tricky one where you've got maybe that vector, and then you got that vector, and you want to work out this vector. Now these directions are often given to you. This might end up being, I don't know, 36 degrees. This might end up being 79 degrees from the horizontal. It all gets tricky. And if I said, well, you know, this one was 3 units long and this one was 7.4 units long, and I said, give me the angle of this one and give me the length, it could be a little bit tricky. Now the way you do these ones, when you get ones like this, is you break them down into components. This red vector is equal to these two vectors. Now these two vectors, we can say both have horizontal components and vertical components. So taking this first vector here, we'll just get rid of these numbers, we don't care about them right now. If I take that first vector, I can break it down into two components, a vertical and a horizontal. And if I take the second vector, I can do the same thing. So each of these vectors, I'll call that one V1 and I'll call that one vector 2. V1 has a horizontal and a vertical component. And V2 has a horizontal and vertical component. So the sum, the red vector, will just be the sum, which is the horizontal and vertical components. Sorry about that real crappy red pen. So the way you can do this is you can do each bit separately. So if I did have the length of this, I forget what I called it. Let's just say the length of this one is 6. So V1, if that's 6, and if that was 36 degrees, then the horizontal is just 6 times the cos of 36 degrees, and the vertical would be 6 times the sine of 36 degrees. So we can then add these guys. We got V2. If that was 8, I think it was 79 degrees. So 79 degrees times the cos of, and I think I said it was 3. So 3 times the cos of 79 degrees, 3 times the sine of 79 degrees gives us our vertical. So if we want to add these components, then we just do it on our calculator. We add this, and we then got the horizontal component for the red vector. And we add this, and we got the vertical component. So we're going to end up with two components for the red vector, that and that. And once we've got those two components, I suppose I could do it. So you just do this on your calculator. So the horizontal components would be cos of 36 times 6. We end up with, well, if my calculator works, let's just check. Always check your calculator. Sine of 30 equals 0.5 means you're in degrees and not radians. So the cos of 36 times 6. Oh, it's giving me real weird answers. Cos, I'll put it in brackets, 36 times 6 gives me 4.8. So that's 4.8 plus 3 times the cos of 79 gives me 0.57. I'll call that 0.6. So that tells me that the horizontal measurement here is 5.4. And we do the same thing for the vertical measurement. And then we'd have these two numbers that represent these two sides. Then I'm sure that you can use your inverse tan rule. What's inverse tan? It's opposite over adjacent. So that would be your vertical measurement divided by your horizontal is the inverse tan. That would give you the angle for the red triangle. And you would just use Pythagoras to get the length. And what you've done with this component method is you've made it really simple to work out what would have been a tricky problem. So using the components for the ones that are not triangles. Of course, you clever maths people will be going, well, I could just use the sine rule, or I could use the cosine rule, and you could. But you can just break it down into components, make a right triangle, use Pythagoras to get the length here, use inverse tan to give you the angle. So that's using vectors, or calculating vectors with components.